Good morning, sir.
Morning, sir.
So how are you all there? Good morning. So let's start the class, okay? 35 students have been joined. So let's start from the discussion. What we left with the last topic. That was we were discussing the complexity of the algorithm. Fine. Okay. We discussed what is space complexity. Now the important matter of concern is that we must know what is time complexity and how we derive this time complexity, and this one is the important aspect of the analysis of the algorithm, as I discussed before. Okay, so what is the time complexity of algorithm? An algorithm, how you can say? Obviously, uh, you are from somewhat what you are interested. You are interested to know what exactly this algorithm or program is taking in terms of time. Okay, what about if you have a number of versions of the algorithm, so you are interested to know what the different versions are taking time to execute to produce the output. I mean, in one sense, you can say it means you are interested to know about the uh, total time to execute to produce the output of a given algorithm. Okay, so obviously, if I'm talking about the time, so time to you cannot define the time. Na? A time is a kind of thing which depends on the machine also. Machine to be depend होता है. जैसे अगर suppose you are executing any kind of program over the supercomputer, so it will take the fraction of the time. Okay, fine. So if it is machine dependent, so how to find out the complexity of any kind of algorithm? Okay, so for that, what one simple approach which you can use, that is suppose if there is some kind of algorithm, like suppose if let me see if there is some example. Suppose see this. If this is the algorithm, something like you are trying to find out the product of two matrices. I think this one is the algorithm for the product of the two matrices. ठीक है, तो कुछ जो प्रोग्राम होता है, जो मेन एल्गोरिथम होता है, किस तरीके का होता है? वी यूज द 3 फॉर लूप इन दिस वे. ठीक है, ये प्रोग्राम तो आप लोगों ने बनाया होगा. ठीक है, तो सपोज यू वांट टू फाइंड आउट द कॉम्प्लेक्सिटी ऑफ दिस प्रोग्राम. So one approach which you can use is based on the cost. Though we do not use this approach, but you must know by using this example, you can understand what exactly we are looking for. Then we can understand the meaning of the asymptotic notation. Okay? So they say, yes, if this is the algorithm, so it is having the instruction like one for loop in line 1, second for loop, then Cij is equal to 0, like the third for loop, and again one assignment statement is something like that for the product. Okay? Then return. So what is the meaning of, if you are trying to find out the complexity of this algorithm, so you must know each means as a algorithm, if it consists of the 5 instructions, so if you are having the idea about how much time one instruction is taking, so you can sum all the time individually taken by the individual instruction, and the total time sum up by these instructions will give you the total time complexity of the algorithm. Okay? So if we are using this kind of approach, so in this approach we must use some kind of variable. That variable is known as the cost, and we must know what is the cost of executing one instruction. Then only we can add up all these instructions cost. That will give you the total time complexity of the algorithm. Okay, so for that purpose, we can assume that, let us say that the cost of executing one instruction is, let us say for first instruction is C1, like the same way for second instruction is C2, like that. Though that cost has no significant meaning, what we assume just like that. So cost, जैसे you can say 1 rupee cost, 2 rupee cost, 3 rupees cost, something like that. Like the same way you can say that suppose the cost of executing one instruction, like for statement number 1 is C1, like statement number 2 is C2, statement number 3 is C3, like 4 is C4 and 5 is C5. ठीक है? तो अब जब आपको इफ यू नो अबाउट द एग्जीक्यूटिंग वन स्टेटमेंट कास्ट, अब आप मल्टीप्लाई कर दीजिए टोटल नंबर ऑफ टाइम वो स्टेटमेंट कितनी बार एग्जीक्यूट हो रहा है, यू कैन गेट द एक्चुअल कास्ट ऑफ दैट दैट लाइन, है ना, दैट स्टेटमेंट. तो this is what the one formulation which you can use to know about the, I mean, though this is not the exact approach, क्योंकि if your algorithm is containing the 1000 number of lines, so just think about that you are trying to find out the 1000 sum of the 1000 steps, okay, like C1x, C2 and C3 and like that. Okay, but this approach just gives us the idea about what exactly the we are looking for in our problem to analyze the time. ठीक है, तो जैसे मैंने बताया कि इफ द कॉस्ट ऑफ वन स्टेटमेंट फॉर स्टेटमेंट नंबर 1 इज C1, 2, तो एक टेबल बना लिया आपने सपोज लाइक दिस. तो एज आई सेड ऑपरेशन 1 इज हैविंग कॉस्ट C1, 2 इज कॉस्ट C2, 3 इज कॉस्ट C3, 4 is cost C4, 5 is cost C5. Okay, now what, as I said that suppose if you will see the instruction 1, it executed for 1 to, means 1 to n number of time, n number of time चलेगा ना for loop. तो आप कह सकते हो the total cost of executing this instruction is m into C1 होगा ना, by number of time executed into cost of that instruction. यही होता है जैसे हम फाइंड करते हैं सिंपल मैथमेटिक्स. like the same way for C2 again ये m into p times चलेगा कि नहीं चलेगा? हाँ, m into p times because it is the inner for loop. चलेगा ना. यहीं से समझिए आप लोग कंसेप्ट को होता क्या है, how we find out the complexity of any algorithm. So what about this inner instruction? M into p times चलेगा ना. Okay, so what the repetition, the total number of repetition for statement number 2 will be m into p plus 1. Don't worry about this thing because we consider no for loop executed p plus 1 time or n plus 1 time. But you can, if you write like m into p, then it's okay. That is correct. So C2 into m into p हो जाएगा suppose. Okay, like the same way for operation 3 कितनी बार चलेगा? ये स्टेटमेंट सेकंड फॉर लूप के अंदर ही है ना, तो m into p टाइम्स ही चलेगा. दिस असाइनमेंट स्टेटमेंट Cij is equal to 0, तो obviously it will be m into p times. Again for statement number 4 it will be executed for how many times? M into p into n times, because here we are it will be executed for k is equal to 1 to n. हाँ ठीक है, तो सपोज ये n टाइम्स चला, ये p टाइम्स चला, अगेन ये k टाइम्स चला. ओके, तो m into p into k हो जाएगा. ओके, या आप ऐसे कर सकते हो m into p into k. देन आफ्टर इफ यू विल ऐड ऑल दिस इंस्ट्रक्शन, तो अगर आप मल्टीप्लाई करोगे, ऐड करोगे, तो आपका जो हाईएस्ट ऑर्डर आएगा ना, आई मीन m into p into n आएगा, बिकॉज यूजिंग हियर mpn or mpk, whatever the notation if you want to use. So what it means that complexity of this algorithm will be approximately order of m into p into n. It means if you see what is m into p into n, so this is suppose n, this is p and this is m, then the total cost, the total running time of this algorithm will be approximately into, suppose it is executing 10 times, this statement is executing for 20 times, 10 into 20 into 30. Okay, so this is what exactly we are interested to know. So by using this approach, you just got the idea about what exactly we are interested in, and what is the meaning of the time complexity of a algorithm. It means we are trying to find out the exact running time. Running time किस पे डिपेंड करेगा? Obviously जो असाइनमेंट स्टेटमेंट है उसका तो कोई मतलब ही नहीं होता. That takes unit time. जैसे सपोज लिखा आपने a is equal to 1. So that is not the dominant factor. The dominant factor is always a kind of those logics, like here the for loop, the looping, while loop. They are going to be repeated again and again to produce the desired output. So that's why if you're trying to find out the complexity of any kind of algorithm, so you must be able to understand how many times that loop is being repeated, or how these things are working to produce the given output. This is one aspect of this is one approach to find out the complexity of a given algorithm by using the cost approach. But we do not use this kind of approach. This is for just to explain you what exactly the meaning of this analysis. ठीक है, तो obviously जैसे ही आप देखेंगे यार if there are 3 for loop, तो आप तुरंत कर देंगे यार इसकी the execution time, the complexity of this algorithm will be order of m into p into n. ठीक है, 2 फॉर लूप होगा, आप बोलोगे m into n टाइम्स चलेगा ना. दिस इज व्हाट एग्जैक्टली द कंपैरिजन एंड द आउटपुट इज प्रोड्यूस इन दिस वे एग्जैक्टली. ठीक है, तो अब the problem is that if you understand what exactly the meaning of this and what we are looking for, so let us try to find out the different way which we can use to do the analysis of the algorithm. Okay, so here comes the role of asymptotic notation. So exactly there are two things. First thing is what? A complexity depends on the machine. A complexity, if I'm saying the running time complexity, it means the total time to execute that algorithm. It means the total time to execute that algorithm is total time to produce the desired output. So for machine dependent, so our approach should be something like that, which should not be dependent on the machine. ठीक है, जो machine पे dependent नहीं होना चाहिए. तो अब कौन सी approach होगी? Then here comes the role of asymptotic notations. ठीक है, asymptotic notation का यहाँ पे role होता है. So what are the asymptotic notation? Asymptote is just like mathematical curve like hyperbola, parabola, log n or n square or n cube. ठीक है, asymptote is a kind of curve. ठीक है, मैथमेटिक्स में आपने पढ़ा ही होगा. ठीक है, तो अब asymptotic notation का यूज करके we always predict the behavior of algorithm using some kind of nature. ठीक है, वो नेचर कैसा हो सकता है? हम बोलते हैं n नेचर होगा. तो n का अगर ग्राफ देखेंगे आप तो इट विल लुक लाइक समथिंग लाइक दैट. हाँ, just see this figure. Some common plots. Can you see this figure? Some common plots. Is it visible?
Yes, sir.
Okay.
Yes, sir.
So what we always try to know कि हम बताते हैं अब rather than saying कि exactly 10 घंटे लगेगा, 20 घंटे लगेगा, 25 hours लगेगा to produce the desired output, to produce the desired. So obviously, just think about programmatically. The code logic, which is based on the comparison, is the code logic. So in totality, what we can say, the total time complexity of the algorithm will be approximately the code logic. जो भी code logic होगा. ठीक है, जैसे यहाँ पे आपने अभी प्रोग्राम में देखा m into n into p के ऑर्डर के करस्पॉन्डिंग था. ठीक है, क्यों था? बिकॉज वी आर यूजिंग हियर द 3 फॉर लूप. फॉर लूप कैसे एग्जीक्यूट करता है? एंड यू नो वेल. Okay, so what here we always say that the behavior of algorithm is just like order of 1 if it is a constant. तो order of 1 को अगर प्लॉट करेंगे तो this is what nothing. एक मिनट जरा, एक फोन आ रहा है. हेलो, हाँ, अच्छा, क्या कर रहा था? हाँ 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 हाँ, अच्छा अच्छा, हाँ. हम्म 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 हाँ 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 हाँ. हम्म हम्म ठीक 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 है, ठीक ठीक, अच्छा. ठीक 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 हो. हाँ 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 हाँ, हाँ, ठीक है, ठीक 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 है, चलो. So this is what we are looking. It's like so order of one is nothing but a constant line. Constant line का graph अगर plot करोगे in between the time and the number of instructions, x-axis पे if you are putting the number of number of inputs like 1, 2, 3, 4, and this is what the time. So order of one is a constant time. A constant line you know that the plot of the constant line is just like a simple line that is parallel to the x-axis. Okay, like the same order, log of n is something like curve is this one, and if you are saying n is just like a bit the same like log n, but if you'll see in terms of the if you'll see this is step. Suppose 3 is the input, so the time for order of n is the complexity of the algorithm is order of n, so it will be somewhat above than the log n. Okay, but the behavior is same like. But which one is better, n or log n? Obviously, log n is better. It is because in terms of input, if you will see the behavior, the time is not growing more rapidly as n is growing. Okay, so this curve is showing how we predict the behavior of algorithm in terms of some asymptotic curves like log fn, n log n, n square, n cube, 2 to the power n. By using this curve, you can easily understand the increasing order in terms of log of n is less than n. यही है ना, आप देखो log of n is less than n, is less than n log n, is less than n square, is less than n cube, is less than 2 to the power n. 2 to the power n तो exponential हो गया ना, ठीक है, 2 to the power n. So this is what the increasing order. If you will move from left to right, this shows the increasing order. तो यहाँ पे आपको समझने की जरूरत ये है कि if the some algorithm is having the behavior n square, ठीक है, another version of the same algorithm is having the behavior n log n, so which version is better? Obviously n log n. ठीक है, तो ये चीज आपको पता होनी चाहिए. So by using this curve, you can easily understand which behavior is better. So here comes the role of asymptotic notation. ठीक है, अब by using these notations, mathematically we try to find out the complexity of the algorithm. This approach is nothing but कोई exact वो नहीं है, but what we predict the behavior of algorithm, and we say it that algorithm behavior is big O of something like that, or omega, what we will see here. Okay, so there are 3 kinds of analysis basically we do. That is the as you know, that best case, average case, and worst case. Okay, and along with these kind of analysis, we use 3 different notations. That is the big O notation, omega notation, and theta notation. Okay. Okay, so the problem statement is that you are interested to know the maximum number of steps to solve a problem. That is the complexity of the algorithm, maximum number of steps. Okay, now you are trying to express the maximum number of steps by using some kind of asymptotic behavior, and that asymptotic behavior is just like the n on n log n, like that. So here comes the role of notation. So this is what the meaning of asymptotic notation. That by using these asymptotic notations, you try to express the behavior of algorithm. Okay, using those asymptotes, like simply like n log n, like that. Okay, so let us see what is big O notation. So big O notation को आप समझ सकते हैं worst case analysis. What is the big O notation? Big O notation is used to express the worst case analysis scenario. ठीक है, अब worst case का मतलब क्या होता है? The maximum number of steps to solve a problem. ठीक है, maximum number of steps. जैसे मैंने बताया ना भाई, एक एल्गोरिथम है, अब it is taking the 10 unit of time maximum. It means 10 unit time ले रहा है एक हमने जो input दिया. So what worst scenario if we are running that algorithm? Worst scenario का मतलब क्या है? Input की size बहुत large कर दिया हमने. That is the worst scenario. Best scenario क्या हुआ? Input is very very small. So best scenario is not particularly the matter of interest. That's why the dominant factor is worst scenario, because किसी चीज का जब हमें worst scenario पता रहता है, we can easily see कि भाई ये तो इसका maximum होगा ही होगा, ठीक है. So that's why big O is also known as the upper bound. ठीक है, जैसे बाउंडिंग थ्योरी अगर आप बोलेंगे, बाउंड होता है ना, लिमिट में पढ़े होंगे लोअर बाउंड और अपर बाउंड. तो अपर बाउंड किसको कहते हैं? बिग ओ नोटेशन को, ठीक है. इट मीन्स द मैक्सिमम नंबर ऑफ स्टेप्स दिस एल्गोरिथम विल टेक, the approximately the order of these things, okay, and that will be expressed by the big O notation, ठीक है. तो अब देखते हैं कि how we can mathematically formulate, how we can mathematically say that what condition exists, then only we can say that this function is big O of another function, ठीक है. So here comes the role of two mathematical functions, that is fn and gn. फंक्शन आपको पता है ना, कुछ भी x के टर्म्स में, n के टर्म्स में. fn है, n के टर्म्स में होगा, जैसे n स्क्वायर प्लस 2n प्लस 1 is one function, n क्यूब प्लस 3n स्क्वायर प्लस 4n plus something like that, this is another function, ठीक है. So what it means, we have, let us consider two function fn and gn, and these are two positive function. मतलब positive function मतलब वही हो गया ना, ग्रो करेगा according to that, means this is not negative function. तो अब अगर if I have taken the two functions, ठीक है, then then only we can say that fn is the big O of gn if there exists two positive constants. Two positive constants, वो कौन कौन से constant हो? C and n naught, such that fn is always less than or equal to C times of gn. For every n is greater than n naught. So whenever the question is being asked to write down what is big O notation, so you need to write this inequality like fn is less than or equal to C times gn. और ये स्टूडेंट्स लिखते नहीं है, तभी आप बता सकते, तभी आप बोलोगे कि this fn is big O of gn. Now what is the meaning of this constant? देखो होता क्या है कि दो फंक्शन है, तो सपोज आपने चेक किया, हिडन ट्रायल यूज किया, ठीक है, आपने कुछ n की वैल्यू डाली, ठीक है, कुछ n की वैल्यू डाली, n की वैल्यू डाली, एक सिचुएशन ऐसा आया फॉर सम n, उसी n को वी आर सेइंग दैट n इज ग्रेटर देन n नॉट. क्लियर? वो n की कौन सी वैल्यू है जहां पे n क्या हो कि n इज ग्रेटर देन इक्वल टू n नॉट हो, ठीक है. जैसे देखो, जस्ट सी दिस ग्राफ, ठीक है, fn है, एक ऐसी कर्व ले लिया गया है, fn इज पॉजिटिव फंक्शन, gn इज अ पॉजिटिव फंक्शन. जस्ट सी at this particular position where n is greater than n naught, x axis पे n है and this number of comparison that is fn at y axis. So at this particular point देखो यहाँ पे जो पे एक पैरेलल टू y axis जो लाइन बनी हुई है, यहाँ पे इस पोजीशन पे हो क्या रहा है, इस पोजीशन को ही बोलते हैं n नॉट पोजीशन, ठीक है. n की वो वैल्यू जहाँ पे fn की वैल्यू ऑलवेज लेस देन और इक्वल टू हो c टाइम्स gn के. This is what the exact meaning of big O notation. So it means then only you can say fn का जो upper bound होगा वो क्या होगा, this will be order of gn, क्योंकि यहाँ पे just see this graph that the fn is in the lower order than the this gn, okay. So what this means, the upper bound of this fn is this gn. It means the maximum बिहेवियर होगा, जो वर्स्ट बिहेवियर हुआ एल्गोरिथम का, वो क्या होगा, इस gn के इक्वल होगा. Suppose if I am saying that 2n square plus 3n plus 2 is big O of n square, so what is the complexity of this 2n square plus 3n plus 1 is big O of n square. ठीक है, कैसे चेक किया हमने कि by using the hit and trial method we will find out some n value for which the value of the function gn will always be less than or equal to means fn की जो वैल्यू होगी will always be less than or equal to some c times gn. So whenever this inequality exists, then only you can say that fn is big O of gn. And what is fn and gn? Fn and gn are two positive function, ठीक है. Let us see example, ठीक है, इस एग्जांपल से आपको ज्यादा क्लियर होगा, ठीक है. So just see, here it is given fn like 2n square plus 3n plus 1. This is what the fn, ठीक है. अब प्रूव करना है fn is big O of n square. So fn is given, now you have to prove that Fn is big O of n square. Kabhi kabhi whenever you are giving the written examination, this kind of question is being asked in your university, like prove that this thing Fn will be given, prove that Fn is big O of n square. ठीक है, तो अब आपको पता चल गया कि the inequality which is which tells us about the big O notation is we need to prove that Fn is less than or equal to some c times Gn. अगर ये प्रूव कर लिया हमने तो हमें पता चल जाएगा, हम we can intuitively say that by using this inequality that Fn is big O of n square. तो यहाँ पे Gn क्या हो गया, n square हो गया, Fn क्या है 2n square plus 3n plus 1. ठीक है भाई, यही तो लिखते हैं Fn is big O of Gn. तो यहाँ पे Gn क्या है n square, Fn is what 2n square plus 3n plus 1. ठीक है, तो आपको यूज करना. तो अब देर इज नो पर्टिकुलर अप्रोच, बेसिकली वी जनरली यूज द हिट एंड ट्रायल मेथड. हम पुट करते रहते हैं n की वैल्यूज, देन वी ट्राई टू फाइंड आउट एट विच n नॉट, मींस n की किस वैल्यू के लिए Fn की वैल्यू ऑलवेज लेस देन और इक्वल टू c टाइम्स Gn. तो जैसे सपोज आपने पुट किया n इक्वल टू 1, n इक्वल टू 2, n इक्वल टू 3, n इक्वल टू 4. सपोज यू गॉट दिस n नॉट एज 4. ठीक है, तो 4 के बाद क्या होगा, द बिहेवियर ऑफ Fn विल ऑलवेज बी लेस देन और इक्वल टू सम कांस्टेंट टाइम. वो कांस्टेंट कुछ भी हो, 6, 10, 5, 15, 13 will be some c times less than or equal to some c times Gn होगा. So this is the inequality, Fn is less than or equal to c times Gn for every n is greater than n naught. ठीक है, तो अब देखो, अब देखेंगे कैसे क्लिक करेंगे. हिट एंड ट्रायल, वी यूज द हिट एंड ट्रायल मेथड. अनदर अप्रोच इज आल्सो देयर. ठीक है, और basically this n naught, so what we found here that for n naught is equal to 1 means n की वैल्यू अगर 1 हो और c की वैल्यू 6 हो, मीन्स अच्छा n की वैल्यू 1 रखेंगे तो इसका एक्सप्रेशन की वैल्यू कितनी होगी, 2n स्क्वायर, दैट इज 2 प्लस 3 प्लस 1, 6 हो जाएगा ना. एंड दिस Fn इज लेस देन और इक्वल टू 6n स्क्वायर, यू कैन से ना. ठीक है, तो हियर वी यूज सम काइंड ऑफ मैथमेटिक्स to find out, to say that this inequality exists. जैसे ही आपको inequality exist मिल गया, you can say that Fn is big O of n square for this n naught, that is equal to 1, and for c here the constant value is 6, so you can easily say that Fn is big O of n square. तो यहाँ पे हिट एंड ट्रायल अप्रोच यूज होता है और इस तरीके से आपको प्रूव करना होता है. वैसे इसमें means there is a direct approach. Obviously the dominant term in this एक्सप्रेशन इज n स्क्वायर. n स्क्वायर के करस्पॉन्डिंग n जो है रैपिडली कम ग्रो करेगा ना, सो विच इज द डोमिनेंट टर्म, n स्क्वायर. तो ऑब्वियसली इसका जो वर्स्ट केस होगा वो n स्क्वायर के बराबर होगा. सो दिस इज वन काइंड ऑफ thinking which you can adopt in your mind, because here you are analyzing if this is the function, तो इसकी वर्स्ट टाइम कॉम्प्लेक्सिटी क्या होगी, ऑब्वियसली द ऑर्डर ऑफ, बिकॉज हायर ऑर्डर टर्म जो डोमिनेंट टर्म है इसमें क्या है, n स्क्वायर है. So if the some function is given in terms of n, you can easily say that the dominant term, that is in case of worst scenario, will be order of n square. ठीक है, क्योंकि n और 1 is a constant, तो जो डोमिनेंट फैक्टर होगा क्या होगा, n स्क्वायर होगा. तो एक ऐसी एल्गोरिथम है जिसमें जो है n स्क्वायर का एक फॉर लूप है, there is a one for loop for n square and there is a one for loop for n and there is a one constant statement. That's why if you are adding these three values, you are getting the total complexity. So obviously the worst scenario, it will take the order of n square. This is what the logic which we use to find out the complexity of an algorithm. If you are saying that this algorithm behavior is order of n square, so you can easily think that the graph of the n square is more rapid than the log n or n and log n. ठीक है, this is what the behavior. So by using hit and trial we can try to find out. Some more examples are given over there, you can check it out. Suppose to show that n is big O of n cube. ठीक है, तो हम again we need to prove that Fn is less than or equal to c times Gn. तो n क्या है यहाँ पे, Fn क्या है, this one 2n square plus 3n plus 1. ठीक है, you need to prove this less than or equal to c times Gn. ठीक है, तो आपने hit and trial यूज किया, n equal to 1 के लिए देखा कांस्टेंट की क्या वैल्यू आई. ठीक है, देन n इक्वल टू 2 के लिए दिया, n इक्वल टू 3 के लिए दिया. ठीक है, तो आपने देखा कि एट दिस लेवल दैट इज फॉर c इक्वल टू 3, ठीक है, फॉर c इक्वल टू 3 दिस n इज ग्रेटर देन n नॉट, वी आर गेटिंग दिस इनइक्वालिटी होल्ड्स. ठीक है, दैट इज Fn is always less than or equal to c times Gn. So by using either this tabular method or by using your approach, mathematical approach, if you are able to establish this inequality, that is Fn is less than or equal to C times Gn, then you can say Fn is big O of n square or n cube. This is what the worst case analysis scenario. That is the big O notation. Like the same में big omega big theta है. 10 minutes बचा हुआ है. Big omega में क्या होता है? This is what the lower bound. Lower bound का मतलब क्या है कि भाई जो बेस्ट सिनेरियो दैट इज द मिनिमम टाइम जो लेगा एल्गोरिथम, वो तो ये टाइम लेगा ही लेगा, ठीक है. मैक्सिमम टाइम आपने बताया हायर बाउंड, लोअर लिमिट एंड हायर लिमिट. So this is what the big O notation, big omega notation is used for the lower bound. Again, the inequality, the definition is same, but here the inequality will be Fn is greater than or equal to C times Gn होगा, ठीक है. तब बोलोगे आप कि Fn is big omega of this Gn, ठीक है. So what is this meaning? Just see this graph that Fn is above the C times Gn. Worst case में क्या था? Fn is below the worst C times Gn, ठीक है. This is what the big omega notation, ठीक है. So जैसे आपको प्रूव करना है कि Fn is given here, Gn is given here, you have to prove that Fn is big omega of Gn. So again you can use the hidden trial method. Then whenever this inequality exists for particular n is greater than n naught, that the value of function Fn is greater than or equal to some constant times Gn, then you can say that Fn is big omega of Gn, ठीक है. तो ये एक बार एग्जांपल्स देखेंगे तो आपको समझ में आ जाएगा. कोई इजी है, कोई इसमें दिक्कत वाली बात नहीं है, बस n की वैल्यू पुट करके चेक कर लेना है, ठीक है. So these kind of question, typical questions being asked whenever we are dealing with a typical scenario की मैं बात कर रहा हूँ. Okay, so like the same way another approach, theta notation is used, and theta is the average case analysis. अब average का मतलब क्या है? I'm not talking about the best, I'm not talking about the worst case, I'm talking about that case, that that scenario which is somewhat in between the best and the worst case. Okay, तो वो कैसे प्रूव होगा? दोनों इनइक्वालिटी को अब मिला लीजिए. अब दोनों इनइक्वालिटी को मिलाइएगा तो बोलिएगा that Fn is big theta of Gn if and only if this following inequality exists, that is Fn is greater than or equal to C1 times Gn, दोनों को मिला लीजिए, and less than or equal to C2 times Gn. So this less than or equal to is the best case, worst case, and this greater than or equal to is the best case. So if you want to prove some Fn is big theta of some Gn, then you must need to prove that Fn is some big O of some Gn, then Fn is big omega of some Gn, then intuitively you can say that Fn is big theta of that Gn, ठीक है. एवरेज केस के लिए ये करते हैं. If you see the graph, so Fn is C1 times Gn less than or equal to, that is depicted in this graph. Fn is less than or equal to C1 times Gn, C2 times Gn, and greater than or equal to C1 times Gn, ठीक है. तो ये चीज for n is greater than n naught. So this is what the one step. ये इसको देखिएगा, नहीं समझ में पूछिएगा, नेक्स्ट लेक्चर में आपको बताएंगे, ठीक है, कि how we will discuss much more about the complexity, ठीक है. ओके, अब अटेंडेंस ले लेते हैं, ठीक है. नहीं, I will upload this lecture. Just go through all these things and let me know if you are facing any problem. और एक बार पढ़िएगा इसको और बताइएगा मुझे. ओके, आकांक्षा, रोल नंबर 1 to 10 आप लोग बता दीजिए.
रोल नंबर 1 प्रेजेंट सर.
ओके.
रोल नंबर 2 प्रेजेंट सर.
ओके.
3 प्रेजेंट सर. 3 प्रेजेंट.
ओके ओके, एक बार बोलना बस.
4 प्रेजेंट सर.
ओके.
5 प्रेजेंट सर.
5 प्रेजेंट.
7 प्रेजेंट सर.
8
प्रेजेंट सर.
8 प्रेजेंट सर.
9
9 प्रेजेंट सर.
10 11 12. अब 10 to 20 बता दीजिए आप लोग, फटाफट बोलते रहिए. ओके ओके. नेक्स्ट
13 प्रेजेंट सर.
नेक्स्ट
11 प्रेजेंट सर.
11 हो गया. 14
15 सर.
14. व्हाट अबाउट 14?
15. हेलो.
हाँ ओके ओके. 15 हो गया. एक बार आप बोलते हैं, मुझे सुनाई दे जाता है. नेक्स्ट 16 17 18 19 20. 20 तक कोई नहीं, 21 टू 30 बताइए। 21 प्रेजेंट।
sir.
ओके
22 present, sir.
नेक्स्ट।
22 present, sir.
हाँ हो गया, एक बार बोलिए, डोंट रिपीट।
Sir, 25 present, sir.
ओके
Sir, 24 present, sir. 24 present, sir.
ओके ओके
26 present, sir.
बोलते रहिए आप लोग।
27 present, sir.
ओके
28 present, sir.
ओके
29 present, sir.
ओके 32 नहीं है। चलो अब बताइए आप लोग 33 टू 40।
33 Anupam Sinha present, sir.
हाँ ओके
34 Anurag Kumar present, sir.
27 present, sir.
ओके
Roll number 35 present, sir.
ओके 40। अच्छा 40 टू 50 बताइए।
41 present, sir.
41 प्रेजेंट। ओके नेक्स्ट।
Sir.
30
43.
43 ओके नेक्स्ट। 50 यार दिख रहे हो 41 स्टूडेंट और है कहाँ सर?
48 present, sir.
ओके
49 present, sir.
ओके
50 present, sir.
ओके नेक्स्ट 50 टू 60 बताइए फटाफट। लेस देन 1 मिनट है, जल्दी से बताओ। 1 51 51 50 51 52 53 54 55 56 57 58 59